Today we're going to talk about how to install the EZ2130 with SPI or Serial Peripheral Interface on the BigTreeTech Octopus Max EZ version 1.0. Now, if you've been watching my tutorials, I've already explained that we have 10 steppers that are located here. And as you can see, we're going to work with the X stepper. So there's a couple of things that we need to set up. Being over in here, we have different power pins that we're going to have to figure out, as well as we're going to have to install our stepper driver, which is right here. Now we're also going to do sensorless homing, which has 2 pins down in here that I'll show you how to connect as well. So the first thing that we're going to do is we're actually going to go over to the BigTreeTech website and see what we need to get. So if we go over to the repositories, what we can do is we can search on Octopus, and you'll find the Octopus Max. Inside here, you can download the actual manual and everything else that's included. But I've already done that and extracted it. So first thing I'm going to do is show you the actual manual and what we have to worry about. So we're working with the SPI stepper mode or Serial Peripheral Interface mode. So in order to use this, we need to set up our sensorless homing, which is going to be a jumper pin right here. And then we have to set the voltage setting. Now we're not doing high voltage on our stepper motor power, which would be a separate power supply, but we're using 24 volts for the entire board. So we're going to use the pins that are above, being the 2 here. So in order to do this, we also have to realize that when working with this, we only have 6 motors that have this configuration. And we're going to be working with just the X stepper. So let's set this up initially and see what it looks like. So I'm going to go over to the desk, and I'm going to take out a pair of tweezers so I can install this jumper. This is going to be for the power, which I've already connected, but it is not energized right now. It's unplugged, as you can see. So the power for this is obviously going to be ground voltage. And so I'm using 24 volts for the voltage. So now that we have the jumper set there, we need to set the sensorless homing jumper as well. Now this one's a slight bit tinier. I think it's 2 millimeters, and I have to line it up and drop it in. So as you can see, I hopefully have that installed correctly. Now one thing you need to remember with this is that when we're installing this, this side's going to be facing you in this direction. So we'll just lock that in place. So we have the bolt right here. The other thing is we're not going to be using an end stop when we're doing sensorless homing. Otherwise, you're going to see smoke come out of your board. So if you're using sensors such as end stops, you'll remove this jumper when using end stops. In that case, it's okay. But if you have that jumper in place, you're going to cause issues with your board. So what I'm going to do is I'm going to take the SD card and place it in here so we can load it with firmware. So I'm going to plug this in, and I'm going to go back over to the computer. On the computer, I'm going to go to VS Code because I've already downloaded the actual Marlin firmware that just came out. So over in here, I've downloaded and extracted it already. So I'm going to go to Open Folder, the Downloads folder, and then I'm going to go to the actual 2.1.2.1, and then again, then select folder. Inside of here, this will load in a moment. You can see that our default environment is a Mega 2560. That is not our chipset. So I'll show you how to change that in just a moment. So there's one thing I didn't tell you about the actual steppers. if we go over here and we search on TMC 2130 for the data sheet, you'll see that inside this data sheet, we can do down in here stealth chop. This is extremely quiet and smooth motion. Also, there's spread cycle. We're not going to be talking about that in this particular case, but if you want more information on how that works, read the data sheet. So let's go over here, and what we're going to do is we're going to set this up. So we're going to go to the Marlin folder, the source folder, the core folder, and boards.h. Inside here, we're going to do a Control F and search on Octopus, if I spell it right. And the particular configuration we're looking for is this one. So we're going to highlight it, right click, and we're going to copy that. Note that it has two different types of actual MCUs. These are called microcontroller units, and that's the big square board in the center, which I'll point to right now so you can see. This is your MCU, and the writing on it is what we're talking about. So, in this case, I'll show you how to set up the one that I currently have. This is subject to change based on the manufacturer. So, let's minimize here. Then we'll go over to the configuration.h. We'll scroll down to our motherboard, highlight where it says ramps, and paste our configuration. Now I'm going to change the serial port for the motherboard to -1. Multiple times people have told me that I should use this one. These are interchangeable, so this and this can be either one, but you can only use one of the two. So usually I use this for the actual TFT display. So now that we have that set up, we have to set up our stepper. So we're going to search on A4988, and we're going to find our stepper in the list. So you can see there's a TMC 2130. We're going to copy that for our TMC 2130, which is the EZ 2130. So I'm going to paste this here. Next, we're going to search on our actual step values. So I'm going to search on, let's see, 80, 80. This will bring us to our actual step values. As you can see, currently it's set to 80. That's the default. When we go over to the advanced configuration and we search on, let's see, 800, for our X stepper, I have to point this out because it's relatively important. It says 16 microsteps. Notice that it says 0 to 256. It actually starts in this case at 16. If we were to change this value being 80 for more resolution to 160, then we need to double this value to 32. If we were to change this value for more resolution to 320, we would then need to double this value again to 64. So I think you're starting to see the pattern of what I'm doing, but that's important to realize. So next thing we need to do while we're in here is set up the actual serial peripheral interface. And what that is if we go over to here, let me show you real quick. Whoop, wrong one. So I don't have it open, so let me go and find it real quick here. So we have the Octopus. I've already downloaded and extracted this. We're going to go to hardware, and we need the pinouts. So as you can see right here, for serial peripheral interface, these are our pins that we need to use. So we're going to have to actually look them up, and those appear. There's actually several other pins, but let's see if we can find them. So we're going to go to, let's see, pins. Then we'll find our board for our MCU. Then we'll find our Octopus Max EZ. And down in here, they talk about SPI for the actual stepping. So we would need to find it in here. And it's located someplace in here. If you look for chip select or CS, you'll be able to find it. Now, it's been a while since I've scrolled through here, and they may have changed the format, but it looks like we have PG14 for the X chip select pin. So if we go back and we check, we can see that it's PG14. So you're seeing the pattern of how this operates. Now that we understand that, we're actually going to configure in the advanced configuration our software for SPI. So I'm going to do a Control F, do SW_SPI, and you can see that it says use software SPI. Those are the ones that we're seeing inside the pins file. So I'm going to do a Control /. Now these other ones are defined already in the actual file. I'll let you find those on your own, but I showed you the chip select for this already. So I'm also going to turn on TMC debug. So I'm going to search on TMC_debug. And inside here, I'm going to turn on driver status monitoring with a Control /. And I'm going to find the second entry for this. And I'll also do a Control / to enable it so we can use the M122. This will give us debugging information. So now that I have that set up, we need to set up sensorless homing. So what I'm going to do is I'm going to go up and then I'm going to search on sensorless and see if we can find it, which we can. So I'm going to hit Control /. Now there may be an issue when we're using this that these values are not correct because in previous versions they were 8. If it is not correct, we can fix it. So you'll know by a noise if it doesn't stop the actual stepper. So when the signal pin gets an overcurrent, it should think that it's at the end of an access. If it doesn't, we'll have to readjust this. So I'm going to show you and possibly make a mistake when I'm doing this, or if it does work, then we're all good. But it depends on your configuration. It could be 8 or it could be maybe 2. But we don't know. It may be even 15, depending upon the type of accesses that you have or axis that you have on your printer. So let's set up the build. So what I need to do is minimize some stuff here so I can see what I'm doing. So we're going to have to set up the INI to build this. So we're going to have to go back over to the INI folder, find our chipset, search on Octopus, and it's not the first one right here. It's actually going to be the second one. So I'm going to highlight this and copy it. Then what I'm going to do is I'm going to go back to the INI, highlight where it says the Mega 2560 and paste it in. So now we're going to build this. We may get an error, but we'll check and see what that is. It may have something to do with inverting an access, but we'll see. So if you see something in red, it's generally a clue that something is broken. If you compile a second time or build a second time and see it again, that generally means you've done something incorrect that you need to fix. So as you can see, we're seeing red for X minimum. So I'm going to hit the Control and click on it and see if we can see what's going on. So it has something to do with inverting X minimum. So I'm going to copy this. And as you can see, it says sensorless homing requires X minimum inverting equal true. That means that we're probably going to be in configuration.h. So we're going to go over here. We're going to hit Control F, paste what we looked for, change this to true, and that will change the actual status that we're working with. So let's try building again. Now, hopefully this will correct it. If it goes in the wrong direction, you can always invert the direction of your axis. So what you could do up in here is actually search on invert. It's probably in the neighborhood of this for movement. So I'd have to look around because I don't know exactly where it is. But you could search on, let's say, direction. And as you can see, it's right here. So if the direction's going the wrong way, you can always change it right here. So let's see if we actually have a building over here. So as you can see, the yellow is a warning. That's okay, we can ignore that. And down in here, you can see that it's still building. So if we get a firmware.bin, then we're successful. So any second now, it looks like we're about to get it. There we go. So we'll right click and say reveal in File Explorer. Over on our SD card, currently we have a firmware.cur from a previous good load. So we're going to right click and we're going to send this to the E drive. On the E drive, you can see now there's two. If the load is successful, it will rename firmware.bin to firmware.cur in all capital letters. If you ever want to reload it, you can always rename this back to firmware.bin and load it again. So keep in mind you can store these also by renaming this file so you don't overwrite it to like firmware.old in all capital letters in case you want to go back to a previous known good configuration. So let's go over to the camera on the desktop, unplug this. I'm going to plug this in right here for the SD card. And I want you to keep in mind that currently it's not powered. We're going to have to connect our access right up here. And then I'm going to connect this, which is unpowered for the board. So I'm going to plug this in to load the firmware. Notice how I don't have jumpers over here because we're using serial peripheral interface and we don't want to reset it by accident while it's running. So the firmware should have loaded. So let's go over to the desktop. I'm going to have to open up Pronterface, so give me a second here. Okay, here's Pronterface. Let's open it up. So as you can see, currently it opened to the actual COM port that we're working with. If you want to double check it to make sure it's correct, you can always click here and type device for device manager. And then when it comes up, you can see what your COM ports are. COM port 1 is default to the computer. And then COM port 23 is our chipset that we're working with. So what we're going to do is we're going to click connect. It says the printer is now online. Let's check our end stops real quick with an M119. As you can see, it says open because we inverted the logic. Otherwise, it would say triggered. Now let's double check the actual stepper being M122 and press enter. And you can see that it says OK. So let's see what happens if we try and actually move it. So what I'm going to do is I'm going to try and home it. I may have to keep my hand on the actual plug to disconnect it if it starts to grind. And then we'll have to make a change in the actual firmware, but let's see what happens. So I'm going to hit home and hopefully it'll stop. Okay, it's grinding. So I'm going to pull the power. I'm going to have to pop out the drive for a second. I'm going to insert the drive in here and then place it back on the computer as soon as I can see where I'm inserting it. There we go. And we're going to fix that. So let's go over to the actual desktop. We'll bring up the actual configuration for sensorless homing and we'll change the 8 to a 2. And then we'll rebuild again. Now you can also do this in EEPROM, which I have not enabled at this moment because I just want to show you how to do it this way first. I prefer not to use EEPROM if I don't have to, but when you're doing something like the BL Touch, you probably will need EEPROM in order to use it, which is memory on the board. So this is almost going to build a lot quicker because some of the stuff is already built in here. So hopefully any second now it'll pop. So it already did. So we'll right click, reveal in File Explorer. We'll right click again, send it to the actual drive, and we'll double check because we just loaded this a few moments ago. So we know we're good. So we'll pop this out and go over to the desk. We'll plug it back in. I'm going to center the actual rail again here so you can see. And then I'm going to apply power back to the PSU or power supply. So it will load the firmware. You'll hear a ding in a second. And then we'll go back over to the desktop and back over to Pronterface. We'll reconnect. So disconnect, reconnect. And the reason I use Pronterface is because I get an actual feedback as to what's occurring here. It does give you feedback in Octoprint and also in Klipper as well in the environments that you're working in. But I prefer using this to show you it in Marlin. So I'm going to do M122. It says everything's okay. Let's double check the end stop. Should be fine. And it is. So let's give it a try again. So I'm going to try and home the access because we know we have the new value of 2 for sensitivity. So here we go. So it still has some grinding. We could probably move it to 1 to make it a little bit more sensitive, which is right here. But I think you've got the idea of how to deal with it. So at this moment, I'd like to thank you for taking the time to watch my tutorial. And please remember to like and subscribe. And also, there's a couple other things I didn't point out about spread cycle, which I'll show you real quick. If we search on, let's try cycle. Well, there we go. So we're in the spread cycle. If you want to use it and correct the actual power supply, I'm using 24 volts. That's another thing you can correct. But at this moment, I want to end this early. And I also want to thank my patrons and the people on PayPal for their donations. And I'll put a thank you note in the end. So everyone take care, be safe, and I'll talk to you later.